At 6 minutes past 6 in the morning, the Titan Crown Casino's overnight risk report flagged an anomaly that no one in the control room could immediately explain. The risk management system generated these reports automatically every night after the casino's busiest hours had ended and before the morning operations teams arrived. The reports were typically routine, showing expected patterns of wins and losses, normal variance in gaming activity, standard fluctuations in the flow of money through different areas of the casino. This morning's report was different, not because it showed a breach of security systems, not because it indicated a hacking incident or network intrusion, not because it revealed a malfunction in gaming equipment or software platforms. The technical systems all reported normal operation. The security infrastructure showed no signs of compromise. Every subsystem was functioning within expected parameters. But buried in the financial reconciliation section of the report was a number that did not belong, a discrepancy that made no sense given all the other data showing normal operations. $89 million was missing from the casino's accounts. The number was so large that the first analyst who saw it assumed it must be a reporting error, a glitch in how the data was being aggregated or displayed. But when the financial team began investigating the discrepancy, running checks and rerunning calculations, they confirmed that the number was accurate. The money was actually missing. It had not been stolen in a single dramatic withdrawal that would have immediately triggered every alarm the casino possessed. It had not been taken from a physical vault in a robbery. It had not been moved overseas in one massive transaction that would have been flagged by anti-money laundering systems and financial monitoring. The money had been taken quietly over a period of time through what appeared to be legitimate transactions. Every approval that should have been granted had been granted by the automated systems. Every safeguard that was supposed to protect the casino's funds had technically worked, had performed its program function, had checked what it was designed to check. Yet somehow, despite all of this apparently proper operation, $91 million had disappeared. The only common factor that investigators would later identify, after weeks of analysis and review of thousands of hours of surveillance footage, was a young man who had spent months sitting quietly on the casino floor. Not gambling at the tables or feeding money into slot machines, not celebrating wins or reacting to losses, just watching, observing, taking notes on his phone, appearing to anyone who noticed him to be someone killing time, perhaps waiting for friends, perhaps just using the casino as a comfortable public space. His name was Daniel Mercer. He was 21 years old when investigators eventually identified him as a person of interest, though his involvement with the Titan Crown Casino had begun several months earlier when he was still technically enrolled as a student. He was an engineering student, or had been until dropping out, at a state university located about 40 minutes from the casino. His chosen field of study had been systems engineering, a discipline that focused on understanding how complex systems with many interconnected components behaved over time, how they could be designed to be reliable and efficient, and critically, how and why they failed. His academic record was complicated and deeply problematic from an institutional perspective. He had entered the university with strong standardized test scores that suggested significant intellectual potential. His high school grades had been acceptable, if not exceptional. He had written application essays that demonstrated curiosity about how things worked. The admissions committee had seen him as a promising candidate who would likely succeed in their engineering program, but his performance had deteriorated steadily from his first semester onward. He had failed multiple core courses that were required for his degree progression, fundamental classes in thermodynamics, structural analysis, fluid dynamics, and control systems theory. These were not elective courses that could be skipped or substituted. They were essential building blocks that subsequent courses depended on. Failing them meant he could not advance through the curriculum on schedule. He was on academic probation by his third semester, his status precarious, his ability to continue his education in serious jeopardy. The university had policies about minimum grade, point averages, and satisfactory academic progress. Daniel was falling below those minimums. One more semester of poor performance would likely result in dismissal from the program entirely, perhaps from the university altogether. He was behind on tuition payments, accumulating debt that he had no clear plan for repaying. His student loans covered only a portion of his total expenses. There were fees and housing costs and textbooks and living expenses that the loans did not fully address. His family, working-class people without significant savings or disposable income, could help only minimally with occasional small amounts that barely made a dent in what he owed. He had applied for scholarships and emergency grants but had been largely unsuccessful, probably because his poor grades made him an unappealing candidate despite whatever intellectual potential he might theoretically possess. To support himself financially and try to keep up with his mounting expenses, Daniel worked night shifts at various jobs that had nothing to do with his field of study and that offered no real career prospects. He had worked for several months at a warehouse doing inventory management, a job that involved scanning barcodes on boxes, moving pallets with electric forklifts, and ensuring that products were stored in their correct locations within the vast climate-controlled facility. The work was physically demanding and mentally numbing, requiring stamina but almost no intellectual engagement. He had worked at a 24-hour convenience store, stocking shelves during the overnight hours, when the store was nearly empty except for occasional customers. This job involved unpacking delivery boxes, organizing products on shelves according to planograms that specified exactly where each item should go, checking expiration dates on perishable goods, and manning the register during the rare times when customers came in to buy gasoline or snacks during the dead hours between midnight and dawn. He had worked doing data entry for a logistics company, sitting at a computer terminal for 8-hour shifts, entering information from paper shipping forms into database systems. This work was tedious and required accuracy to avoid errors that would cause problems downstream, but it required almost no thought or creativity. It was the kind of work that could be done while mentally disengaged, following simple rules repetitively without ever needing to make meaningful decisions. None of these jobs paid well. All hovered around minimum wage or perhaps $1 or $2 above it. None offered benefits like health insurance or retirement contributions. None provided any training or skill development that would help with career advancement. They were simply ways to earn money to survive, temporary stopgaps while Daniel tried to figure out what to do about his academic situation and his increasingly unclear future. His professors, when asked about him later during the investigation into the casino theft, gave mixed and sometimes contradictory assessments of his abilities, his character, and his potential. Some remembered him primarily as someone who rarely attended class lectures, preferring to skip them entirely rather than showing up even for important sessions. He missed lab periods where hands-on work was required. He turned in assignments days or weeks late, if he turned them in at all. Some assignments he simply never completed, accepting zeros rather than putting in the effort to finish the work. These professors saw Daniel as a student who lacked discipline and commitment, who was wasting his intellectual potential and his tuition money by refusing to engage seriously with his education. Others remembered him quite differently and had more nuanced views. They recalled that during the occasional times when he did actively engage with course material, he demonstrated remarkable insights that suggested deep understanding. One professor specifically recalled a structural engineering project where students were asked to analyze a proposed bridge design and identify potential failure modes. Most students had focused on obvious issues like load capacity and material strength. Daniel had identified a subtle failure mode that none of the other students and not even the teaching assistants had noticed. He had recognized that under certain combinations of wind loading and traffic patterns, resonance effects could amplify vibrations in ways that would compromise the structural integrity of specific components. His analysis had been thorough and technically sophisticated, showing understanding that went well beyond what the assignment required or what typical undergraduates would demonstrate. Another professor recounted a similar experience from a course on control systems. Daniel had analyzed a proposed automated manufacturing system and had pointed out that the feedback loops designed to maintain stability would actually create instability under certain operating conditions. He had explained how time delays in sensor readings would interact with the control algorithms to produce oscillations that would grow rather than dampen. Again, this was insight that required understanding the system as a whole rather than just analyzing individual components. One professor said that Daniel possessed an unusual and somewhat troubling ability to understand how complex systems behaved, particularly how they failed under stress or unusual conditions. He could look at a system design, whether it was mechanical, electrical, or computational, and identify the specific points where cascading failures would occur. He could predict how errors would propagate through interconnected components. He could see vulnerabilities that were not obvious from examining individual parts in isolation. This was a valuable skill for an engineer, but Daniel seemed more interested in finding ways systems could fail than in designing systems that would succeed. The same professor added that Daniel just did not seem to understand, or perhaps actively did not care, about how school worked as a system. He did not grasp or accept that academic success required consistent engagement with requirements and deadlines, rather than occasional moments of brilliance or deep insight. You could not skip 3 weeks of classes and then show up and ace a single exam and expect that to be sufficient. You could not turn in exceptional work 2 weeks after the deadline and expect full credit. You could not demonstrate that you understood concepts deeply while refusing to complete the routine homework assignments and lab reports that were required to show that understanding. He had the raw intelligence and analytical ability to excel in his chosen field. Multiple professors agreed on that assessment. With consistent effort and engagement, he probably would have been one of the top students in his cohort. But he lacked either the discipline or perhaps the fundamental interest to follow through on the routine work that academic success demanded. He was analytical to what some saw as a pathological degree, interested in understanding complex systems deeply but seemingly impatient with or actively dismissive of the structured processes and formal requirements of university education. He wanted to explore topics that interested him in the ways that interested him on schedules that he chose, which was fundamentally incompatible with how universities actually functioned as institutions. Daniel had one particular obsession that multiple people who knew him during his time at the university mentioned when they were interviewed by investigators. He was deeply fascinated by the concept of predicting complex system failures before they occurred. He would talk at length to anyone who would listen, and even to some who clearly would prefer not to listen, about how most catastrophic failures in engineering systems were not truly random, unpredictable events, but were instead the inevitable result of flawed assumptions that had been built into how those systems were originally designed and how they were subsequently operated. He believed passionately that if you understood a system deeply enough, if you could build sufficiently accurate models of its behavior that included all relevant components and all the feedback loops and dependencies between those components, you could predict not just that a system would eventually fail, but exactly when the failure would occur and precisely how it would manifest. He thought that most major engineering disasters, from bridge collapses to power grid blackouts, to chemical plant explosions to aircraft accidents, could have been predicted and potentially prevented if someone had built proper models and had paid attention to the warning signs that those models would have revealed well before the actual catastrophic events occurred. This obsession had increasingly started to interfere with his actual required academic work, rather than supporting it or complementing it. Instead of focusing his time and energy on completing the problem sets in lab reports and project assignments and exams that determined his grades and his academic standing, Daniel would spend hours, sometimes entire nights, building elaborate computational models of systems that he found personally interesting. He would try to identify the specific points where those systems would break down under stress or when subjected to unusual input conditions. He would test his models against historical failure data when he could find it in engineering case studies and accident investigation reports, refining his modeling approaches and his analytical techniques based on how well his predictions matched what had actually happened in documented real-world disasters and system failures. His professors tried repeatedly to redirect this evident energy and intelligence toward his actual required studies. They suggested that he could pursue these interests through proper institutional channels, perhaps as independent research projects that could earn academic credit, or as senior thesis work that would count toward his degree requirements, if he would just first complete the foundational courses and maintain minimum academic standing. But Daniel seemed fundamentally unable, or perhaps actively unwilling, to conform to the structured curriculum and the formal requirements. He wanted to investigate whatever interested him whenever it interested him, not follow a predetermined path through required courses with standardized syllabi and fixed assessment schedules. After failing several courses and facing the imminent prospect of being dismissed from the university entirely, Daniel made the decision to formally drop out for a semester, or perhaps permanently, though he left that option ambiguous in his withdrawal paperwork. He needed to work full-time and try to save money to address his mounting debts. He needed time and space to figure out whether he actually wanted to continue pursuing his engineering degree through the conventional academic path, or whether he should try to find some other way forward that might be more compatible with how his mind actually worked and what genuinely interested him. He took a part-time job at a small business located near the Titan Crown Casino and began spending substantial amounts of his newly available free time, which was considerable given his minimal work schedule and complete lack of academic obligations inside the casino building. Not to gamble, which would have been pointless given his financial situation and lack of interest in games of chance. Daniel had no interest in gambling and certainly no money to spend on it, even if he had been interested. Instead, he went to the casino specifically to observe its operations. He treated the massive entertainment complex not as a place for recreation or leisure, but as a living machine, an enormously complex system that he could study and attempt to understand at a fundamental level. He found locations where he could sit comfortably for extended periods and watch operations unfold around him in real time. He brought his laptop computer or his tablet device. He took extensive notes in digital files. He observed patterns of activity. He timed processes. He documented sequences of events. He watched people as variables in a system, understanding that individual human behaviors might be unpredictable, but that in aggregate and over sufficient time periods they became highly predictable statistical distributions. He could see how crowds moved through spaces, how they made decisions about where to go and what to do, how their behaviors influenced each other through social dynamics. He observed software systems as logic layers that made automated decisions based on program rules and data inputs. He studied human oversight as latency in the system, recognizing that points where human decision-making was required created delays and introduced inconsistencies because humans were slower and more variable than automated processes. He analyzed automation as fundamentally an expression of assumptions, recognizing that automated systems operated based on expectations about how things should work, rather than through continuous active verification of how things were actually working at any given moment. Daniel was not interested in the casino games themselves, not in the mathematics of odds and probability that determined whether a particular bet would result in a win or loss for the player. Those mathematical relationships were well understood and not particularly interesting from a systems perspective. He was interested in something much more fundamental and complex. He wanted to understand how the casino as an institution decided that its operations were secure and its assets were protected. How did it determine that everything was functioning normally? How did it distinguish between acceptable, normal variation in outcomes and actual problems that required investigation and response? What signals and data did it actively monitor? What thresholds would trigger alerts and interventions? How did the different monitoring systems and oversight processes communicate with each other and coordinate their activities? Over weeks that extended into months of careful observation and documentation, Daniel began to develop a comprehensive theory about how casino risk management actually functioned beneath its sophisticated technological surface. He realized something that seemed crucial to understanding the fundamental vulnerabilities that were inherent in how these systems were designed and operated. Casinos did not actually monitor reality in real time in the way that most people, including probably most casino employees, would assume they did. Instead, they predicted reality using mathematical models and then operated based on the assumption that actual outcomes would match their predictions closely enough that small discrepancies would not matter and would resolve themselves over time. The casino's risk engines were sophisticated pieces of software that had been developed over years by teams of mathematicians and programmers. These engines forecasted acceptable windows of financial loss based on complex analysis of historical data about gaming outcomes, mathematical models of probability and expected value, and real-time monitoring of current activity patterns and volumes. The engines calculated continuously what levels of losses the casino should expect to see over various time periods ranging from hours to days to weeks. They predicted how much variance from the calculated averages was statistically normal and therefore acceptable. They established dynamic thresholds for when variance became large enough or persistent enough to be concerning and to warrant investigation by human analysts. Then, critically, from Daniel's perspective, the systems assumed that outcomes would naturally converge toward the predicted values over sufficiently long time periods. If the casino was experiencing losses that were higher than expected in the short term, if the numbers over the past few hours or even a full day showed results that deviated from the model's predictions, the risk engines were programmed to assume that this represented temporary random variance rather than a systematic problem. The systems would not immediately conclude that something was wrong. They would give the situation time to resolve itself naturally because their underlying mathematical models told them that regression to the mean was statistically inevitable given enough time and enough independent events. Daniel recognized this pattern and this vulnerability because he had studied similar conceptual flaws in various engineering models and control systems during his coursework and his independent investigations. When multiple predictive systems depend on each other for their operation, when one system's outputs become inputs for another system's calculations and decisions, and when there are inevitable delays between when predictions are initially made and when outcomes are eventually verified against reality, the result is often a form of blind institutional confidence. Each individual system within the network trusts that the other systems are operating correctly and producing reliable outputs. Each system assumes that any discrepancies it observes will be resolved by downstream processes that it does not directly control or monitor. No single system takes full responsibility for independently verifying that reality actually matches the collective predictions that emerge from the network of interconnected models. The delay between prediction and verification, between expectation and confirmation, was measurable. Daniel spent months carefully observing and recording data about how long it took for different types of discrepancies to be noticed and investigated. He tracked how the automated systems responded to various patterns of activity. He noted when human oversight stepped in and when it deferred to software recommendations. And once this delay was measurable, once Daniel understood the timing and the thresholds and the decision logic, he realized it was potentially exploitable. Not through traditional hacking or system intrusion, not by defeating security measures or stealing credentials, but by creating conditions that would fit within the casino's predictive models while producing outcomes that diverge from what those models expected in ways the systems would not immediately recognize as problems. The preparation phase of what Daniel eventually did took months of careful work. This was not impulsive or reckless. Despite his academic struggles and his financial desperation, Daniel approached this project with the methodical discipline that he had never been able to apply to his schoolwork. Perhaps because this was a system he had chosen to understand, rather than one he was being forced to study. Perhaps because the stakes were so high that they focused his attention in ways that academic grades never had. He mapped how automated approvals flowed through the casino's operations. He identified which types of transactions required human review and which were processed entirely by software. He documented the decision trees that the automated systems used, the sequence of checks they performed, the data they considered relevant. He understood that these systems were fast and consistent, but also rigid and predictable. He noted when human oversight deferred to software recommendations. He observed that casino employees, faced with hundreds of decisions during their shifts, tended to trust the automated systems unless something seemed obviously wrong. If the software approved a transaction, if the risk engines said the activity was within acceptable parameters, human operators rarely questioned those assessments. They had been trained to trust the systems, to believe that the expensive software and sophisticated algorithms were more reliable than human intuition. He tracked how alerts were prioritized and delayed. Not all alerts received immediate attention. Some were classified as low priority and were added to queues that might not be reviewed for hours or even days. The classification logic determined how urgently different types of anomalies needed to be investigated. Daniel learned what characteristics made an alert low priority versus high priority, and he understood how to structure activity to trigger only low-priority alerts that would be delayed. He identified which discrepancies were automatically dismissed by the system without human review. The casino's monitoring software had logic that determined when discrepancies were within acceptable variance and when they represented actual problems requiring investigation. Small discrepancies, discrepancies that fell within expected statistical ranges, discrepancies that could be explained by timing differences between systems, these were often automatically dismissed as normal operational noise rather than signals of real problems. He learned how expected variance was calculated by the risk engines. He studied the historical data that informed the models, the assumptions about normal distribution of outcomes, the confidence intervals that defined acceptable ranges. He understood that the models assumed random variation around predicted means, and he recognized that this assumption created an opportunity. If he could create non-random variation that looked statistically similar to random variation, the models would treat his activities as normal when they were actually directed toward a specific outcome. Throughout all of this preparation, Daniel never triggered alarms in ways that would have drawn attention to his activities or his presence. He never tested limits aggressively, never pushed boundaries to see where the defenses were strongest. That would have been the behavior of an amateur, someone who did not understand systems thinking. Instead, Daniel waited. He observed. He built his models. He refined his understanding. He waited until he was confident that the system would behave exactly as his predictions indicated. Until he understood not just what the casino's defenses were designed to do, but what they would actually do under specific conditions that he could create. Until he could forecast the casino's responses with the same confidence that the casino's own risk engines forecasted gaming outcomes. The theft itself, when Daniel finally executed his plan, occurred over a carefully timed period that exploited everything he had learned about how the casino systems operated and monitored themselves. The activities were spaced across different systems and different time periods in ways that prevented any single monitoring system from seeing the complete pattern. Each system saw only part of what was happening, and the part it saw appeared normal according to its programmed expectations. Approvals appeared independent because they came through different channels and involved different automated processes. No single approval authority saw enough of the overall activity to recognize that approvals were being orchestrated rather than occurring naturally. Each system performed its checks, found that its specific criteria were met, and granted approval without knowing what other systems were approving at the same time. Nothing crossed alert thresholds that would have triggered immediate investigation. Daniel had calibrated his activities precisely to stay below the limits that would generate high-priority alerts. Individual transactions were sized to appear routine. Timing patterns matched normal operational rhythms. Classification codes indicated ordinary business activity. Everything was carefully constructed to blend into the background of legitimate casino operations. Oversight systems assumed that convergence would occur, that any temporary discrepancies would resolve themselves over time as the predictive models expected. This was the fundamental vulnerability that Daniel exploited. The casino's risk management assumed that variance was random and would regress to predicted means. The monitoring systems were programmed to be patient, to allow time for natural resolution, to avoid creating false alarms by reacting too quickly to temporary fluctuations. But convergence never came. Because Daniel was not creating random variance that would naturally correct itself. He was directing outcomes systematically toward a specific goal. He was creating conditions that looked statistically similar to random variation, but that were actually carefully controlled to produce cumulative effects that the models did not anticipate. By the time analysts noticed the pattern, by the time someone finally compared data across enough systems and time periods to see that something systematic was happening, rather than random variation, $91 million had already exited the casino's operational ecosystem. The money had moved through a series of transactions that had each appeared legitimate when they occurred. Each transaction had been approved by automated systems following their program logic. Each had been properly documented in the relevant databases. Each had satisfied the technical requirements for compliance with internal policies. The money had left quietly, without triggering the kind of dramatic alarms that would have immediately locked down systems and initiated emergency response protocols. It had left legitimately on paper, meaning that all the records showed proper approvals and appropriate authorizations according to the rules programmed into the systems. And it had left irreversibly in practice, meaning that by the time anyone realized what had happened, the transactions could not be unwound or reversed without complex legal processes that might not even be successful. Daniel did not vanish overnight when his work was complete. He did not suddenly disappear in ways that would have seemed suspicious or memorable. Instead, his exit from his previous life was gradual and could be explained by circumstances that appeared entirely normal for a struggling student facing academic and financial difficulties. He stopped attending the few classes he had been still nominally enrolled in. Since he had already been missing class frequently, this was not particularly remarkable to anyone who knew him. He formally withdrew his enrollment from the university, completing the paperwork that indicated he was taking time off for personal and financial reasons. This was not unusual for students in his situation. Universities saw students withdraw temporarily all the time for various reasons. He closed his student housing, moving out of the apartment he had been renting near campus. He left his part-time job without providing much notice, simply stopping showing up for shifts. While unprofessional, this was also not particularly unusual for low-wage service jobs where turnover was high and young workers often left without proper notice. There was no celebration that anyone observed, no sudden lifestyle shift that would indicate he had come into money, no luxury purchases, no expensive trips, no flashy displays of wealth that would attract attention or create memories in people who knew him. Just absence. Just the gradual disappearance of someone from the systems and spaces where he had previously existed. His digital traces ended gradually as well, in ways that seemed more like someone powering down a process than crashing a system. His social media accounts, which had never been particularly active, simply stopped being updated. His email responses became less frequent and then stopped entirely. His phone number eventually went to a disconnected message. He faded from the digital landscape in the same way he had faded from the physical spaces of his former life. The investigation into Daniel Mercer and the missing $91 million was extensive and involved multiple regulatory agencies, law enforcement organizations, and private security firms. Gaming regulators demanded detailed explanations for how such a massive theft could occur in a licensed and supposedly well-controlled casino. The casino's insurance companies sent investigators to determine whether they would be liable for covering the losses. Law enforcement agencies examined whether crimes had been committed and who could be prosecuted. What the investigators found was deeply frustrating from a law enforcement and regulatory perspective. There was no evidence of illegal access to computer systems. Daniel had not hacked into the casino's networks. He had not stolen passwords or credentials. He had not defeated authentication systems or bypassed security controls. The technical forensic analysis found no traces of unauthorized system access. There was no evidence of code intrusion or malware. The casino's servers and applications had not been infected with malicious software. No backdoors had been planted. No system files had been modified. The code that ran the casino's operations was the same code that had been there before Daniel ever started his observations. There was no evidence of coordination with casino employees. Daniel had apparently acted alone. He had not recruited insiders to help him. He had not bribed staff members to look the other way or provide information. He had not formed conspiracies with dealers or pit bosses or security personnel. Every employee who had worked during the relevant time period was interviewed and investigated, and none appeared to have been involved. There were no clear rule violations that prosecutors could point to. This was perhaps the most frustrating aspect for the legal team. The transactions that had moved the money through the casino systems had followed documented procedures. They had been approved by authorized system components. They had satisfied the technical requirements for compliance. While the cumulative effect was clearly theft, each individual transaction appeared to have been processed correctly according to the casino's own policies. There was no clear criminal act that fit neatly into existing legal frameworks. Prosecutors debated how to characterize what Daniel had done. Was it theft if the casino's own systems had authorized the transactions? Was it fraud if he had not technically lied or misrepresented anything? Was it computer crime if he had not actually accessed the computer systems in unauthorized ways? The legal analysis was complicated and uncertain. Everything had functioned as designed. The casino systems had worked exactly the way they were programmed to work. The problem was that the design included assumptions about how the systems would be used and what kinds of threats needed to be defended against. Daniel had understood those assumptions well enough to exploit them without technically breaking the rules as they were written. The casino had not been attacked in any traditional sense. There had been no assault on its defenses, no penetration of its security perimeter, no defeat of its protective measures. Instead, it had been anticipated. Daniel had predicted how the systems would behave under specific conditions, and he had created those conditions to produce outcomes that benefited him while staying within the boundaries of what the systems would approve and process. Daniel Mercer was never formally charged with any crime. The legal complexities and evidentiary challenges made prosecution uncertain. His name was never publicly released in connection with the theft. The casino chose not to publicize the details of what had happened, because doing so would reveal vulnerabilities in casino operations that might encourage others to attempt similar schemes. Law enforcement agencies maintained files on Daniel and continued to search for him, but he was never located despite extensive efforts. Casinos across the industry, learning about the incident through their professional networks and security channels, quietly rewrote their forecasting models and risk management approaches. The revelation that someone could exploit the gap between prediction and verification, that they could use the casino's own trust in its models against it, forced a fundamental reconsideration of how risk was managed. Risk engineering teams were restructured and in some cases entirely replaced. The engineers who had designed the predictive systems that Daniel exploited were seen as having failed to anticipate this type of attack. New teams were brought in with instructions to assume that adversaries might understand the systems as well as the designers did, that predictive models could be gamed by someone with sufficient knowledge and patience. Predictive systems were compartmentalized so that no single system had visibility into enough of the overall operation to fully orchestrate the kind of attack Daniel had executed. Different monitoring systems were deliberately kept separate, with different data sources and different analytical approaches, to ensure that gaming one system would not allow gaming all of them simultaneously. But the money was never recovered. The $91 million that Daniel had taken remained gone. The complex web of transactions that he had created made it extremely difficult, if not impossible, to trace where the funds ultimately went. The casino absorbed the loss, though it impacted their financial performance and led to management changes and restructuring. The case became a turning point in how casinos and other institutions thought about security and risk management. It demonstrated that the most dangerous person in a complex system was not necessarily the one who could break it through technical exploits or physical force. The most dangerous person might be the one who could understand it deeply enough to predict exactly what it would do under specific conditions, and who could use that predictive knowledge to manipulate outcomes while staying within the bounds of what the system considered normal and acceptable. Daniel Mercer had been a struggling student on academic probation, someone who could not navigate the relatively simple system of university coursework and requirements. But he had possessed an unusual ability to understand complex operational systems, to model their behavior, to identify their assumptions and vulnerabilities. He had applied that ability to the casino with a discipline and focus that he had never shown in his academic work. And the result was one of the most sophisticated thefts in casino history. Somewhere, presumably, Daniel lived with the proceeds of his analytical work. Whether he felt justified in what he had done, whether he viewed it as a legitimate application of his engineering skills or as a crime he rationalized, whether he felt guilt or satisfaction, no one knew. He had vanished as completely as the money he had taken, leaving behind only questions about how someone so young and seemingly unsuccessful could have accomplished something so sophisticated. The theft had been accomplished through prediction, through understanding the casino systems well enough to forecast their behavior under conditions that Daniel could create, through exploiting the gap between what the systems expected to happen and what actually happened when someone with sufficient knowledge deliberately created specific patterns of activity, through weaponizing the casino's own confidence in its predictive models and risk management systems. $91 million, taken not by force or deception in any traditional sense, but by someone who had figured out exactly what the system would do next, and who had used that knowledge to direct outcomes that appeared normal to automated monitoring while producing results that transferred massive wealth from the casino to himself. The story served as a reminder that in an age of increasingly sophisticated automated systems, the greatest vulnerabilities might not be technical flaws that could be patched or physical weaknesses that could be reinforced, but conceptual gaps in understanding how those systems could be exploited by someone with the patience and intelligence to truly understand them.